Hey everyone. So previously we saw that alcohols could be oxidized to make carboxylic acids in the presence of acidified dichromate. Today's video is going to be about how carboxylic acids make a whole series of the homologous compounds. So they have a homologous series of organic compounds. They're not hydrocarbons anymore. So organic compounds that have the carboxylic acid functional group, which is C with a double bonded oxygen atom, then OH, or you could write it like COOH. That is a functional group. You know, functional groups are specific atoms or specific group of atoms that control the properties of the compound. So it's a C double bonded oxygen, then OH, and then the R could mean anything. It could be H, it could be another carbon, it could be a chain of carbons. So this is the carboxylic acid functional group. The oxygen and OH have to be on the same carbon. Their general formula is CnHNNO2, or you can say Cn-1H2n-1 COOH. Let's try writing the general formula and let's make the formula for other carboxylic acids. For like methanoic acid, carbon 1, then hydrogen double times 1, O2. So it's CH2O2. You could use the other general formula and you could say C1 minus 1 H2 times 1 minus 1, which is obviously 2 minus 1, COOH. So it becomes no C, there's no C over there, H1 COOH. That's methanoic acid, and they both have the same meaning. You could write both the formulas. That's totally your goal. Similarly, for ethanoic acid, N is equals to 2. So it becomes carbon 2, hydrogen 2 times 2, then obviously O2. So it becomes C2H4O2. If you use the other general formula, it becomes C2 minus 1, then H2 times 2 minus 1, because N is the value of 2 over here, then COOH. It becomes C, then H3, because 4 minus 1 is 3, and then the COOH is a constant. So it becomes ethanoic acid. Again, both the formulas are same. You could pick any formula based on your choice. For propanoic acid, N is equals to 3. So it's C3H 2 times 3 and then O2. It becomes C3H6O2. You could use another general formula, which is the bigger one, and you could say it's 3 minus 1 for C. Hydrogen becomes 2 times 3 minus 1, which means 6 minus 1, then COOH in the constant value. So it becomes C2H5CO2H. That is also propanoic acid. That has the same meaning over here. Similarly, let's try more. Let's get along with the practice, For butanoic acid, N is equals to 4. So it becomes C4H4 times 2, O2. It becomes C4H8O2. For the other formula, it becomes 4 minus 1, hydrogen 2 times 4 minus 1, which is 8 minus 1, then COOH. It becomes C3H, obviously 8 minus 1 is 7, then COOH. That's again butanoic acid, because you see 4 carbons. That is butane. For pentanoic acid, it would be C5H5 times 2, then O2. So C5H10O2, pentanoic acid. For the other formula, it would be C5 minus 1, H2 times 5 minus 1, which is 10 minus 1, then COOH. Carbon becomes 4, hydrogen becomes 9, and then the COOH makes it pentanoic acid. Let's recall the idea that why do we call it a carboxylic acid in the first place. So we should know they are weak acids. If we have gone through the videos of the acid-base chemistry, we would remember that what a weak acid is. Weak acids are compounds that partially, incompletely is also a possible word, so that partially or incompletely dissociate in water. You could also say ionize in water, that's the same thing. So dissociate in water to produce H plus ions. They give out the H plus ions. So we should know one thing, that all the carboxylic acids, for example this one that I'm drawing right now, it's a 3-carbon acid. It's obviously a propane something. It's got all the hydrogens from those carbons in the corner. These hydrogens are here, and one of the carbons has a carboxylic acid functional group. It has the OH and then the double bonded oxygen as well. Now this is the carboxylic acid functional group, so it becomes propanoic acid. It's not propanol, it's not propene, it's propanoic acid. 3 carbons and then a carboxylic acid functional group. So this is my carboxylic acid group over here. When it goes into water, it shows a reversible reaction, and in the presence of water, the carboxylate part becomes separate and the H becomes separate. H gets a positive charge and then the rest of the molecule gets a negative charge. So that's dissociation. The OH bond is breaking down. So H is released as a hydrogen ion, and then the rest of the molecule, the entire oxygen part, carbon chain part, this is the negative ion. We call it the propanoate ion. Propanoate, ethanoate, depending on the acid. So imagine you have a test tube which has the carboxylic acid sample, ethanoic, propanoic, whichever acid, and you take a dropper which has universal indicator in that. If you add few drops of that, the color gradually turns to yellow, and that indicates that the carboxylic acid sample was actually a weak acid. So that is a test for weak acid, guys. You add few drops of universal indicator, it turns yellow. Their pH range is from 4 to 6.9, and they give a yellow color when few drops of universal indicator are added. So when universal indicator is added. Now let's talk about their reactions. So reactions of the carboxylic acids. Obviously we're talking about with alkalis because that is the foremost thing that comes in our mind, right? So imagine you have a carboxylic acid which is ethanoic acid. It has 2 carbons and the carboxylic acid functional group. The H from the acid and the OH from the alkali make water. What happens to the remaining parts? The remaining part of the acid goes with the Na, or goes with the metal part. So the metal part goes to the carboxylic acid part. Imagine you have a propanoic acid. The H in the corner goes with the OH of the alkali and it makes water molecule. You get a water molecule from the H of the acid and OH of the alkali, and then the remaining part of the alkali goes with the remaining part of the acid. So H and OH are combining over here, which is our main concern. H has a positive charge and obviously the alkali has OH with a negative. So over here what happens is there is a partner exchange. The H from the acid, the corner one, the carboxylic acid part 1 makes it. So if you cancel the ions, you get ionic equation like this, that hydrogen ion goes with the OH ion to make water molecule. The remaining acid part, the remaining part of the acid goes with the remaining part of the alkali. So carboxylic acid provides the hydrogen ion, the alkali provides the OH minus ion, and then it makes a water molecule which is neutral. This is the specific ionic equation for all neutralization reactions. So we have to remember this equation. It's always constant for all the acids. In the next video, we'll talk more about their behavior and their esterification. So stay tuned guys, we're gonna learn more about them.